Up Garage Racer, another batch of useful info. We have a new video about engines. As you've probably noticed, we've reached the newest and latest BMW engines. The last ones were the B48 and B47. And now we found the top, latest 3-liter diesel from BMW, the B57. It's going to be interesting. Grab some popcorn and let's go. It's advised to watch our previous BMW engine review videos before this one, especially on popular models and their unique features. The B47, a 2-liter diesel from BMW and the predecessor of our featured engine. The N57 engine is a 3-liter diesel. In this video, we will constantly refer back to these previous reviews, so it's better to watch them to stay informed about what's happening. Throughout our review, you will admire this beautiful G30 550D, a 550 diesel in an impressive configuration. With 4 turbochargers, powered by the B57 engine. Bitch, come on.
The most powerful diesel in the world.
In 2009, it has a 6-litre V12 diesel with 500 horsepower and 1,000 newton meters of torque, which is nuts.
The most powerful diesel in the world, that's right. Let the emotions flow. The B57 began production in 2015, and as usual, the first high-performance engines are installed in what model? The 7 Series. It was installed in the G11 730D. There are 3 versions of the B57 engine. 1 turbocharger with 265 horsepower, 2 turbochargers with 320 horsepower, and 4 turbochargers with 400 horsepower, as in this particular model. Imagine, 400 horsepower from a diesel engine. You don't even need to chip it, neither the N55 nor the B58. This is just mind-blowing. I started to think about the fuel consumption at such power levels. Sergey Beyko mentioned that the average is now around 9.2 to 9.3 liters. Previously, we reviewed the B47, which had an average consumption of 6.5 liters. The G30, similar in size to the 7 Series, some E38 model, a big ship like that, has a fuel consumption of 6.5 liters in the city with a 3-liter diesel. The real fuel efficiency, basically the B Series, is economical. The single-turbo version was installed in almost all models starting from the 3 Series. We have the G20 330D here. This diesel engine with 1 turbo was also used in the X3, G01, and G02 models. The X5s, X7s, and of course in the 5 Series and 7 Series. The twin-turbo version is quite similar to the N57, the previous 3-liter diesel. It also had the 4D badge and was installed in the 5 Series, 7 Series, X5s, X6s, and X7s. So the badge is 40D. The most powerful version has the 50D badge. But I think you all know where this engine was installed. Oh, these are the 5 Series, the 540 diesel, just like the one we have now. By the way, it's all-wheel drive. There was no rear-wheel drive option because it doesn't make sense with such torque. In the 7 Series, it's the 750D. And in the X5s, X6s, and X7s, we have the 50D. Let's start with the most popular and accessible version of the B57, which has 1 turbocharger and produces 265 horsepower. The situation here is similar to that of the B47 engine. If you haven't watched the review, be sure to check it out. The difference with the previous N57 model isn't as drastic as it was with the gasoline engines, like the N20 and B48, for example, and the N55 and B58. In the diesel engines, the modifications and updates aren't as extensive. I checked the catalog, and there aren't as many similar parts to the predecessor as there were in the first version of the B47. The situation here is more comparable to the latest version of the B47. So the only similarities here are the chain, and by the way, the connecting rod is the same. There are interesting similarities with the chains. The situation is exactly the same as with the B47 engine. There are 3 chains, 2 in the timing system and 1 for the oil pump. For those asking about the chains, what's up with them? In our previous review of the N57, we mentioned that at around 250,000 to 300,000 kilometers, the chain definitely needs to be replaced. Here we have a similar situation because the chains are the same as those on the B47. on the N47, on the N57. So imagine that the upper chain is exactly the same and the oil pump chain is also identical. This means 2 out of the 3 chains are the same, while the middle chain differs from the N47 but is the same as on the B47. In other words, the situation hasn't improved at all, not one bit. And even considering the most powerful versions like the one with 4 turbochargers, given the loads on the engine and the torque generated by the crankshaft, the chains could fail even sooner, possibly before reaching 200,000 kilometers. So, our recommendation regarding the chains is to replace them at 200,000 kilometers to avoid questions later about whether it's 250,000, whether it's rattling or not. Basically, protect yourself and continue driving with peace of mind. This engine has a closed-type aluminum block, similar to the B58, which provides more rigidity and allows it to handle significantly more power than an open-type block. Unlike its younger sibling, the B47, which had cast iron liners in an aluminum block, this one features an aluminum block with a plasma coating of steel in the cylinders. It comes with a forged crankshaft, and the connecting rods are identical to those from the N57. And let's not forget the important component of every BMW diesel engine, the torsional vibration damper. You need to pay close attention to it after 100,000 to 150,000 kilometers of mileage. Typically, issues with the engine's sealing connections are addressed around 200,000 kilometers when the chain replacement is on the table, at which point the valve cover and oil pan are removed. Questions may arise only regarding the gaskets of the oil filter, and I'll probably get tired of repeating in every video about BMW diesel engines that BMW diesels do not have systems like Valvetronic or Vanos in the engine block, which makes them simpler in terms of hardware, reduces the likelihood of breakdowns, and increases reliability. Now let's move on to the air intake system of the 3-liter diesel with a single turbocharger. The B57 with 1 turbo operates similarly to its predecessor, the N57, except for one system, which we'll get to shortly. As usual, air enters through the filter, like the mass airflow sensor, MAF, and goes to the turbocharger. Here, there's a turbo with electronic control of the geometry, meaning it has an actuator that adjusts the vanes to change performance. We clearly explained the geometry in our video about the M47. We'll insert a link here. Check it out for a detailed explanation of how it works. The system with an electronic actuator for geometry control is reliable. There are no issues here. Next, the air flows as usual through the boost pipe to the intercooler. And from the intercooler, it goes through the charge pipe to the intake. After about 10 years, there may be an issue if, for example, the turbocharger or engine starts leaking oil, or if the PCV, positive crankcase ventilation valve, which has a membrane, tears. If the crankcase ventilation system fails, there will be an increased amount of oil in the intake. You might start seeing oil dripping or collecting at the joints between the boost pipe and charge pipe on the intercooler. However, this is a common issue for all BMW diesels we've discussed. Next, the air from the charge pipe enters the intake manifold. The situation here is similar to the N57, where there are flaps installed. The EGR, exhaust gas recirculation, system is also present. It allows exhaust gases from the intake manifold, along with soot, to pass through a valve and an intercooler, which cools the gases to prevent significant changes in the air-fuel mixture and excessive heating of the intake. However, this process can lead to heavy contamination of the intake manifold with soot from the exhaust gases. Regular viewers of our channel know that while the issue of clogging was not particularly severe in the M47 and M57 series, starting with the N47 and N57, it has become a critical problem for BMW diesels. The intake can become so clogged that the flaps installed there may no longer function properly, leading to boost errors and irregular performance, resulting in insufficient power and erratic engine behavior. Therefore, we usually recommend inspecting the intake every 100,000 kilometers to see what's going on. Additionally, the accumulation of soot greatly depends on the quality of the fuel used. Because, if we are currently at war, there may be some low-quality diesel fuel. We recommend checking the intake and EGR valve more frequently than every 100,000 kilometers. The intake flaps can be removed, but BMW does not endorse this. If something happens with the flaps, it means you need to replace the intake manifold. And those who watched the previous video about the 2-liter B47 engine know that, just like in the B57, there is a problem with the EGR. This in relation to the N57 is a part that tends to break more frequently. The valve itself fails more often and can get clogged or blocked. But it can open and stay open, allowing uncontrolled passage, for example. The engine control unit wants to close it, but it won't close because it's already clogged. This soot allows exhaust gases to enter the intake uncontrollably, which can lead to issues similar to those seen with the B57 engine. The intake plastic manifold can swell, melt, and develop holes large enough for a finger to fit through. In addition to the EGR valve issues, there's also the problem with the EGR cooler. In the B-series engines, there's a common issue where coolant runs through this cooler to reduce the exhaust gases to a normal temperature. It can happen that coolant can leak through the metal into the exhaust gases, and combined with the hot exhaust gases and soot, it can ignite. This could lead to an actual engine fire. That's why BMW initiated a recall for the free replacement of the EGR cooler. You can check with any dealer using your VIN to see if your vehicle is part of this recall, meaning they can replace the cooler for you at no cost. Everything seems similar to its predecessor, the N57, if not for the new changes in the B57 engine. This is what we mentioned about the B47 engine. It features not a simple EGR system, but a dual circuit system. So we just talked about the high pressure circuit. What does this mean? It means that the exhaust gas is delivered directly to the intake. And at the intake, so when the car is under heavy load, there is high pressure. So the EGR doesn't operate all the time. It may only work at idle or partial throttle when the pressure isn't too high. In the B series, BMW added a low pressure circuit as well. When you're under heavy load, there's high pressure, making it ineffective to feed poorly burned gases into that system. So where do you send them? And they need to be directed before the turbocharger, where there is a vacuum. That's why they designed an additional outlet beyond the exhaust manifold. There's another EGR pipe, again with a separate valve and a separate cooler, a separate radiator, which connects to this pipe right after the filter. After the MF sensor, there's a pipe that also supplies exhaust gases and soot. This sounds cool, but as you can imagine, it could lead to soot clogging not only the intake, but potentially also the turbine blades, though that's unlikely given the high speeds involved. Then comes the intercooler, the charge pipe, and the boost pipe. It doesn't present a great outlook. It will be interesting to see the condition of these components after 200,000 to 300,000 kilometers, particularly how they handle soot and what issues arise. Plus, we've already mentioned the crankcase ventilation membrane, which can tear after 100,000 to 150,000 kilometers. To summarize everything about the intake system for an average BMW user, if you suddenly experience power issues, rough running, or irregular engine performance, this is mainly likely due to two reasons. Either there's a problem with the EGR valve, which may be stuck open or clogged, or the intake manifold has become clogged and the flaps are not working, or you may have an issue with the turbocharger control. Traditionally, we move on to the ignition system, which for diesel engines is the glow plug system. Those who watched the video about the B47 engine know that BMW simplified the system in the B series by eliminating the glow plug relay. In earlier N57 and M57 versions, we mentioned that when replacing glow plugs, the relay had to be changed as well to avoid any issues. Here, the function of the glow plug relay has been integrated into the engine control unit, DDE. BMW incorporated power transistors that provide the necessary current to the glow plugs for proper heating. This system is designed to preheat the intake air before starting the engine in cold weather. The logic in the B series is that it activates when temperatures drop below 5 degrees Celsius. Above 5 degrees, it doesn't activate, but as the temperature approaches 0 and goes down to -5 or 10, the glow plug heating time increases. And as usual, we transition to the fuel delivery system. This is where one of the key features of the B series is revealed, which is how BMW managed to achieve greater performance, lower fuel consumption, and improved environmental friendliness. This is achieved primarily through the fuel system, which enhances performance mainly by increasing pressure. Here, The pressure reaches 2,500 bar. Just imagine in the M57 versions, it was around 1,300 bar, while in the N57, it ranged from 1,600 to 2,000 bar. Here, it's 2,500 bar. In the highest version, like ours with 4 turbos, the pressure in the rail is even 2,700 bar. To achieve this, a more powerful fuel pump was designed. Plus, piezo injectors have been installed. Piezo injectors can open very quickly, several times per cycle. The rapid opening of the piezo injectors creates a good spray pattern, improving the quality of fuel injection. This allows for atomizing and burning the mixture more efficiently, which positively impacts emissions. And it also enhances fuel efficiency. So this is the secret of the B series compared to the N series. In terms of reliability, everything is fine. The submersible pump, high-pressure fuel pump, and injectors have a long lifespan and durability, although there are still some instances where they have failed. Regarding the engine cooling system, it's mostly traditional. It features a mechanical pump. However, this pump resembles the latest B57 design, where there is an additional valve controlled by vacuum. A separate regulator manages the vacuum, which opens this valve during engine warm-up, preventing coolant from circulating through the block and cylinder head. The coolant circulates internally during warm-up. The valve opens and the pump circulates coolant within itself. Since it is mechanical, it can circulate, unlike the N-series gasoline engines, which had electric pumps that simply wouldn't activate, preventing coolant circulation. With the mechanical pump, this is not an issue, as it can only circulate coolant within its own cycle. BMW implemented this design in the latest versions of the B47 and B57 engines. So far, there haven't been any reported failures of the pump, thermostat, or any hoses, but we will see how these engines perform and at what mileage any issues might arise. It will be interesting to make a video in a few years. The G series features the same caps on the expansion tanks as the F series, which are recommended to be replaced every 2 to 3 years for diesels, and more frequently for gasoline engines. Moving on to the auxiliary equipment, everything is standard here. There is no hydraulic rack, it has an electric one. The generator and the air conditioning compressor remain. They usually don't fail. This requires high mileage for failure, which is considered on a case-by-case basis. However, there are standard recommendations for the rollers and the generator belt, which is recommended to be replaced at 100,000 to 150,000 kilometers. Moving on to the exhaust system. Here, everything is standard. The exhaust manifold, turbocharger. There's again one outlet for the EGR under high pressure. And then comes the particulate filter. And there's an outlet for the second EGR circuit under low pressure, which also includes a radiator. I've already mentioned all of this. However, since the B series engines comply with Euro 6, for this reason, diesel engines are required to establish a system. AdBlue is a urea injection system in a specific part of the catalyst. Urea is injected there, initiating a chemical reaction with exhaust gases that significantly purifies them. Let's move on to the chip tuning section. If in the predecessor, the N57, the standard power was 258 horsepower, and chip tuning raised it to about 320, 330 horsepower, then here I think the trend is similar. You can add a percentage of power. This means you can achieve around 330, 340 horsepower with stage 1 or stage 2 tuning. Considering the complex dual-circuit EGR system, you can also do eco-tuning by disabling the valve that operates on the high-pressure EGR circuit and the second valve on the low-pressure circuit. Plus remove the diesel particulate filter, DPF, and disable it in the system as well. Here we've gone through our traditional checklist for the 3-liter diesel with a single turbo. What are the differences for the B57 with twin turbos? With 2 turbos, boost control becomes more complex, requiring additional vacuum lines and vacuum regulators. However, power increases to 320 horsepower. In the N57 predecessor, it was 313 horsepower. Some might complain about it being 313, but in the pre-facelift version, it was 306 horsepower. Well, I mean, it's just 14 horsepower difference, or rather 5 horsepower, 14. Haven't you seen? The competition M5 with 600 horsepower only has a measly 25 horsepower difference. 25 is 1/4 of 6, 4%. Who even needs that? Oh shit. In short, as you can see, the owner of the B57 with twin turbos gets more power and better fuel efficiency. A fuel compared to the owner of the N57. In the distant future, there could be problems with vacuum lines. If you have an issue with boost at around 200,000 or 300,000 kilometers, the first thing to check is the vacuum lines and pressure regulators. Now let's move on to the cherry on top, the B58 with 4 turbos. In the predecessor, the version with the 5.0D badge had 3 turbos producing 365 horsepower. Here we have 4 turbos producing 400 horsepower. But there are many more differences compared to the predecessor, especially in contrast to the single turbo version. We've removed the protective cover so you can see the significant differences in what's happening here. The biggest changes are, of course, in the intake system. I won't go into detail. I'll just say that there are 4 turbos and a multi-stage boost system. There are separate videos and information online about this system, so I won't bore you with the tedious explanation of how it works. No one really needs that, especially the owners of these cars. They just want to... they really don't care about what's going on there. They drive it for 100,000 and sell it, basically. In short, there are a lot of vacuum lines, numerous flaps, a bunch of turbos, and various geometries. Anyway, I can't even imagine what will happen when it hits 300,000 kilometers. Well, first of all, will the bearings or the crankshaft survive such a load at that mileage? But we'll just have to wait and see. It's really interesting. And plus, I'm sure it'll be straightforward. No one will even bother figuring out how it works. There are about 5 to 10 pressure regulators, and with the hoses, it's like an anthill in there. Everything will just be replaced. BMW even made separate colors for each vacuum line so we wouldn't mix them up. Can you imagine? Colored vacuum lines. There are so many of them. I think it will just be replaced as a whole. They'll just remove the entire assembly. Go to a turbo service or buy everything new and get all the vacuum lines replaced with original ones, so everything is color-coded and neat, so that when will this thing even reach 300,000? If it makes it to 600,000, then the next mechanics will at least see how it was originally. But what immediately stands out is the change in the intake system. This is not the typical air intercooler that is usually here. Instead, it features a liquid intercooler system. It's more akin to the systems found in the B58 and B48 gasoline engines. Here, take a look at this. The intercooler, which as you can see, has a dedicated system just for it, of antifreeze. There's already a separate reservoir here. Of course, there's no mechanical pump. Instead, like in the B48 and B58, there's a dedicated electric pump. This adds another layer of complexity to the system. Engine cooling. These cars are relatively new. And we are now in the year 2024. Well, it's interesting to think about what will happen in 2027, for example, when something like this breaks down. Owners who bought them from the dealership for around $120,000 or over $100,000 will probably be driving different cars by 2035. It'll be interesting to see who will own these cars then and whether they'll be able to properly maintain it. Maintaining a car is a delicate matter. They might consider retrofitting it to a single turbo version, for example. And I'm back here again, and I almost forgot. And the issue of burnt intake, again caused by the EGR valve. Look, there's a metal intake manifold, but it's not just to prevent burning if the EGR valve gets stuck open. It's designed to withstand an incredibly high boost pressure. Imagine if before it was 2 bar of boost, here I think it could be around 3 bar. And a plastic manifold might not handle that load. We're all waiting for the end of the war when we can race this car against, for example, 3-liter diesels with 1 turbo, with 2 turbos, chipped or not. It would be interesting to see how this car performs compared to a chipped 540. Diesel and gasoline versions on the B58, specifically at stage 2. So I think many of you are also curious about how this performs. Owners of such cars buy them with the feeling that they're kings of the road, with top fuel efficiency and top power. They think they can just step on the gas and take off. However, I believe owners of the weaker versions, whether single turbo or twin turbo, want to race and think, yeah, we can chip the twin turbo version to around 400 horsepower and easily beat that 550. Who needs 4 turbos? 2 turbos are simpler, better, and more efficient. By the way, leave a comment about what you think and what you would choose for yourself. It's clear that many think Sergey Bako is suggesting 2 turbos. I think our pictures of the 4 turbos scared a lot of people. BMW discontinued the production of the 4 turbo version in 2020 and replaced it with a different twin turbo version. Well, one of the reasons was likely the tightening of emissions regulations, which the engine didn't meet. Another reason was the lack of reliability due to the heavy load on the poor 3-liter diesel. Can you imagine? There used to be the M57, which had 190 horsepower. And now we're talking about how they strapped 4 turbos onto this poor 3-liter diesel, squeezing out 400 horsepower. Although I thought to myself, well, they extract quite a bit from the 3-liter gasoline engines in the M models. Around 400 horsepower, even up to 510 horsepower like in the M58. And so that's normal. However, the torque loads aren't the same. The issue with the diesel is that the torque here is like huge, so it can't handle the loads. In terms of durability, the pistons, connecting rods, and bearings just won't withstand that kind of stress. The summary for the engine is similar to the one from our review of the B47. Overall, the engine has become more fuel efficient, quieter, and more powerful, and more environmentally friendly, though that usually doesn't concern many people.
Entire ecosystems are collapsing. How dare you?
Now, but on the downside, there's the issue with the EGR valve, plus the addition of a second low-pressure EGR circuit, which could lead to some consequences in the future, though we don't know for sure yet. There's also the possibility of driving the most powerful diesel engine in the world at the time of its release, and you could even forget about chipping it and just enjoy driving with low fuel consumption around 9.3? As for the chains in the B series, they didn't really surprise us. It's the same as with the predecessors, with a replacement recommended at 200,000 kilometers. We'll wrap up the video with a question from Sergey Beko. Would you buy a car like this? I thought to myself, it would be pretty cool to have a version like the 5.0D, especially up to 150,000 kilometers before all those interesting issues start popping up, and see how it performs. But in peacetime, I think we should film the most popular version, which is the 540 gasoline on the B58. Personally, I would find that really interesting. It would be interesting to chip it, for example, to stage 1 or stage 2. Let's say stage 1, which is a light chip for the B58, bringing it to around 400 to 420 horsepower. I'd love to try racing it against that car and even sit inside, feel the difference between the two, and compare the torque. It would be great to see what the diesel offers and whether it's worth it. You understand that the price of the 550 is about twice as much as the regular 520s, 530s, or the more affordable 540 G30s. Meanwhile, the 540 with a chip offers excellent reliability and a great alternative to that car. It would be interesting, not just for owners, but as a driver, to compare the driving characteristics of the diesel relative to the 3-liter. The top gasoline version of the B58 from BMW. But for now, during wartime, we're unlikely to conduct such an experiment because support the armed forces of Ukraine. To swiftly drive the occupiers out beyond the borders. Glory to Ukraine, death to the occupants. Leave your comments about which version of the B57 you would choose, what car you prefer, and your thoughts on the turbos, and so on. Or maybe you choose the 540 with the B58 gasoline engine. So we're interested in your opinion. Leave your comments and we're off to work.